I'm going to show you how to create a P chart in Microsoft Excel. Um, the P chart is used for visualizing the proportion non-conformance in a lot. For example, you're looking at this data. Imagine that this is from a online retail store. They get this customer complaint. So every 2,500 products they shipped, how many complaints they receive per 2,500 products. So in this case, the first day of the month, on Monday, let's say they are collecting this data for 1 month, and then first day of the month they took 2,500 products, and then they found that they received 15 complaints on that day. They ship those products. Now, so to create a P chart, let's name this some symbols, define some symbols for this. So sample size typically expressed in AN. This is basically subgroup size in quality control world. So you can say sample, or you can say subgroup per sample. So there's subgroup 1, subgroup 2, subgroup 3, and so on. Now, complaint, this is basically proportion defective times the sample size in the lot. So to calculate P, it is basically equal to the proportion. So NP divided by N. So that will give us the proportion non-conformance in that sample. Now we want to find out the average proportion non-conformance, which is P bar. On an average, how many defectives there are. So what I can do, I can then sum basically all of these products and then all of the complaints. That will give me so all of the complaints divided by all the products will give me the total proportion of non-conformance, that is P bar. So I can first sum this column, and then I can simply copy this cell and paste it here. That's gonna calculate all the sum for all of these data. So if I now calculate the proportion, it's gonna be equal to this, and I'm gonna freeze that because I want to copy that all the way up to there, so I can plot the graphs. And freeze it again, copy down. So this is the average defective proportion defective in the entire lot that we tested, the average value. Now we're going to calculate the upper control limit for P bar, or simply you can say upper control limit, and then we're going to calculate lower control limit for proportion. This is just indicating that we have done a P chart. This subscript P is kind of redundant because you have this P here and then P bar here. So you could simply have UCL, LCL, upper control limit, lower control limit. So to calculate upper control limit, let me copy the formula right there. Like that. So that's upper control limit, and then that's lower control limit. These are the formulas that we use to calculate the upper and lower control limit. Basically, this is the standard deviation. So we go 3 standard deviation up, 3 standard deviation low, making total 6 sigma, 6 standard deviation. So equal to P bar this plus 3 times SQRT square root, and then P times 1 minus P, close the parenthesis for a square root. In fact, the deviation is within the square root, so divide by square root of sample size, which is this one. That's it. This is the upper control limit, and then the lower control limit equal to p bar minus 3 times SQRT square root of p times parenthesis 1 minus p close the parenthesis divide by n, which is this one, close the parenthesis, close the parent. So that's it. This is the lower control limit. Now all I have to do is just select these 4 columns like that, and then insert some type of chart, maybe a line chart, something like this. You have the upper control, lower control, and so let's title this. This is the P chart, trial P chart. We didn't really revise anything, so I'm gonna name that trial. Let's have the axis labeled. This axis is the proportion defective. Or complaint, same thing. This axis is the subgroups. In this case, we have basically day of shipment. So that's it about the trial P chart.